Hey everyone, welcome to another Unity tutorial. In this one, we're going to look at how to make a 2D Othello. I'm going to presume that you guys know the basic Othello game. That way I don't have to go into a bit of explanation about that, and that way we can just focus on the programming of making the Unity equivalent of it. So there's two basic objects that are going to be used in this game. There's going to be the board that you're playing on, and then there's going to be the token. So let's start with making the tokens. So we're going to go to Game Object, we're going to go to 2D Objects, and we're going to choose Sprite. Just going to rename this. We can call this Token. Down here you can see there are two images. These were simply drawn in an external paint program. I use Anime Studio version 11. You can use whatever you want. They're just PNGs that after I save the images, I dragged and dropped them from the folder into this asset area. That's it. It's that easy to get an image into, or any asset really, into Unity. So we're going to click on Token, and we're going to just take the chip image and put it there on Sprite. And just like that, you now have a token. So we're going to add some functionality to this later. For instance, you need to have a white or a black token. So that's the reason why I'm using white, because since you can change the color of a token, you don't have to make two different token objects. You can make just one, or should I say, to be more specific, you don't have to make two different prefabs. You can make one prefab and just change the color in real time. So that gives us our token. So by dragging it from the scene and putting it down here, it now gets turned into a prefab. Or prefab is an object that's been saved as an asset. That's all it is. So if you click on this, you click on Open Prefab, you'll see that the various components are still here. The transform component, the sprite component. If there were colliders or there was script, it'd all be here as well. Okay, so since we created our prefab, we can delete this one from the scene. And now we're going to make the board. Rather than having a single image for the board and trying to create 64 areas that you can click on, instead, our object is going to be just one square that you can click on, and then you multiply it out 64 times. And you'll see just how efficient that is. So, Game Object, 2D Object, Sprite. You can rename this Square. Again, over here, there's no sprite, so we just take the image, drag and drop it, and there's the beginnings of our square. Now, for this object, since we want to be able to click on it, and actually I'm just going to move this over so it's not getting blocked by the camera icon. Since we want to be able to click on this, we need to add a collider. So, over here, Add Component, Physics 2D, Box Collider, and we're just going to zoom in a little bit. You can't really see it at the moment, but there's actually a green border, and that indicates the parameters of, or should I say the perimeter, excuse me. That's the perimeter of the collider. So here you can see there's a box collider component now. You're going to click on Edit Collider, and see these green dots? You can actually just move these in. So I'm doing this so is that we're not going to have overlap with the border. We don't have overlapping colliders. And we do have to make this a trigger. Basically, a trigger means that it's not going to be treated as it's solid. So if you were to have two objects that were both triggers and they collide, they'd actually pass through each other. That really isn't applicable to this particular example, this particular game, but it still does need to be a trigger or else you can't click on it. Okay, so we have transform component, so it has position, rotation, scale. Our sprite, so that gives it its image. The box collider, so we can detect collisions, include making it clickable. Now what we really need to do is we need to add the script, which is going to control the functionality. So right click, create C#, and we'll call this ClickCon for click control. So we're going to click on our square. Go ahead and take the script, just drag and drop it. It's just another component. And now we're going to go ahead and open that up. So we need to do a couple of things. First, we need the square to be we need the square to be aware of the token. So what we're going to do is we're going to, up here, outside of start, outside of update, but within public class, we're going to do public transform capital T, and we're going to name this object that's going to represent, that's going to really hold that token object. So we can actually just call it token obj. I like to try to come up with a naming convention. That way, when I see this populated in a list, I'll say, oh, that's an object. So I know that it's a game object as opposed to, say, a variable. So we save that. Now what we need to do is we need to have this object be instantiated when we click on this square. So outside of start, outside of update, we're going to type on mouse down. And if you're using Microsoft Visual Studio, you'll see private void appear before it, the parentheses appear after it, and the squiggly brackets for what you want to have actually happen inside here. So this is saying that when the mouse is clicked down, left click down on the object the script is attached to, which is the square, we want something to happen. Well, what do we want to happen? We want this to be instantiated, and whenever I say instantiate, think spawn. So again, you hear about enemies spawning or something spawning. To do that, you're using the instantiate command. So we need to instantiate. There are 3 arguments for instantiate. What is going to be instantiated, where it's going to be instantiated, and the rotation of the object that's going to be instantiated. So what is going to be instantiated is the token obj. Where is it going to be instantiated? We want it to be instantiated right on top of the square that you are clicking. So transform, small t this time, dot position. Oops, sorry. Let's try that again. Position. And then the third argument is the rotation. So we'll use the token object's own rotation. So token object dot rotation. In this case, the rotation really isn't making much of a difference because no rotation has been applied. But in some cases, it would matter as far as you might want the object that's being spawned to match the rotation of the object that's doing the spawning. Okay, so what's being instantiated, where it's being instantiated, and the rotation. Now this, if there's nothing preceding this, as you can see, there's nothing preceding this. This grabs the position of the object the script is attached to. So the script is attached to the square, so transform.position, therefore is equal to the position, the location of that square. So that means if I make 20 different squares in 20 different positions, or to be exact, 64, each one will return a different value for this because each one has a different position. So this really scales well to put this functionality onto just one square, and then you compose the board out of a bunch of these individual objects. Okay, so let's go back to Unity. So what we need to do is we click on our square, and there we go, token object, sorry. And so here's the token that we created. We'll put it there. So this prefab is now going to be instantiated whenever this is clicked on. Now, I tend to recommend that if you're doing any kind of collision, including mouse clicking, you really want to test it first, but I already tested this before recording, so I know it's going to work. But generally speaking, if you're testing collision, you're probably going to want to put in like a debug command and have something print down here to the debug log, just so you know that the click is work, because sometimes more difficult, more complex collisions may fail, and there could be a range of reasons why it fails. It could be a simple typo. So you want to make sure that the collision itself is working, or in this case, the mouse click. Okay, so let's run this. Actually, we're going to make one more change. Since this is a 2D environment, but objects can stack in a 2D environment, you have to specify the order in the layer. So right now, when you make a 2D object, so for sprite renderer, order in layer always defaults to 0. The higher the number, the higher order in layer. So we're going to make this 1. And then we're going to go back to our square. If you come here, you'll see that this one is 0. So 1 is higher than 0. The token will spawn on top. It'll cover up the square. And the reason why you have to do that is because there is no z-axis that's being acknowledged in a 2D environment. So you basically fake the z-axis by using the ordering layer. Okay, so let's run this just to make sure the core functionality is working. So if I click on this, the token should appear on top of it. Absolutely perfect. So what's going to happen is, since I made it work for this one square, and I think I already mentioned this briefly, if I multiply this out by 64, I now have that functionality baked into all 64 squares. So let's now take that square, turn it into a prefab, delete it, and now we're going to use the instantiate command again, but this time the instantiate command is going to be used to instantiate the blocks. That way we get an 8x8 grid. So what we're going to do is we're going to create a GM object. There's absolutely nothing special about a GM object. Calling it GM, Game Master, is basically to let you, the programmer, know what you're using that object for. It's not a special type of object. Just naming it reminds you that you're using this to maybe manage game flow, something that isn't really associated with any one object. Maybe you're using it as a holder for some of your static variables, that kind of thing. So we're going to game object, create empty, and we're just going to call this GM. Its position does not matter in the least because we're going to ignore its position. There's no collider, there's no image, it won't get in the way. If you feel like, you can move it out of the frame, but honestly, not a whole lot of point because, again, all it has is location and nothing else. But again, if you want to move it out, feel free. So what we're going to do is we're going to create a second script, and that second script is going to be attached to the GM object, and the GM object is going to spawn this square. So right-click, create, C#, and we're going to call this, let's call this game flow, because even though at the moment it's going to be just for spawning the board, looking forward in the next video or two, I'll probably also utilize it for some more game functionality. Okay, so what we're going to do is we click on our GM object. Now this we're not going to turn into a prefab because it's not going to be instantiated. We want this to be here even before the scene is created. That way it's controlling things. So let's take game flow and put it onto the GM object, and then we're going to open it up. And I'm going to go to Notepad so I don't mess this up. So right now, I showed you how to use the instantiate command. The instantiate command is being used on demand. You click and it instantiates. But what if you want a whole bunch to be instantiated? You don't want to use a whole bunch of instantiate commands. You want to be able to reuse one instantiate command. So here's what we do. I'm going to use a for loop. Don't worry, I'm going to explain this. I just didn't want to mess it up, so I jotted it down ahead of time. So in the start section, actually, let's do let's create the object first. So public transform, again, capital T, and this will be square obj. So similar pattern. On the square object, we created an awareness of the token object. Now for the GM object, we're going to create an awareness of the square object. So in the start section, and just so you know, this happens before the first frame is updated and only happens once. So this is typically where you're going to put, if you're creating an environment, you're going to put it in here. If it's a small environment, if it's a large environment, then you might do that over time. But if you want the entire map to appear, the entire level to appear as soon as the game starts, you have to do it in the start area. So now what we're going to do is we're going to put in that for command, and then again we use our squiggly brackets. So what this is saying is that while these conditions are true, whatever is in here is going to happen over and over again until this stops being true. So let's read through it. So x is the variable, and it's of a float type. its initial value is -4. So this is creating the starting value and the starting type and the starting name. A variable named x of a float type starts with -4, semicolon. So long as it's less than this value, so x less than 5, semicolon, this will then happen. So as long as x does not meet this criteria, or it's still beneath, in this case, it's less than 5, then we're going to add 1.2 to its value. The reason why is that's exactly how much space is needed to line these squares up next to each other. Like I said, I already tested this ahead of time. That's how I know that 1.2 is the right amount. And you have to drop in the F so it doesn't get confused, because that dot would confuse it. So you have to put in an F so it knows it's a float. Okay, so as long as these conditions are being met and these conditions are occurring, with every pass of these, we want something to happen. Well, we want the object to be instantiated. Like I said, we already looked at this in the other one. So instantiate, in this case, it is the square object that's being instantiated. And this is what I was talking about, because you can see it in the list. So I say, oh, square obj, that's an object. Again, if your program gets bigger, you might have lots and lots of variables. It makes it easier to remind yourself what it is. Okay, so again, we said 3 arguments: what's being instantiated, where it's being instantiated, and the rotation. Now, in this case, like I said, we're ignoring the position of the GM object, so we can't just do transform position. That's what this is doing. This is calculating the x. So what we're going to do is we're going to do transform. Oh, sorry, my apologies. Losing my mind. New vector 2. In other words, we're saying that we're coming up with a new position that has 2 vectors, x and y. So we've already calculated x, so we just drop x in there. For the minute, I'm going to put in a constant for y, but then we'll go back just so this isn't too complicated the first time. So x, comma, and y will just be, let's do like +4 and see how that looks. Comma, and then we said square object dot rotation. We want to use its own rotation. And then semicolon. Okay, so it looks a little bit more complex, but it's the same basic idea. What is being rotated, where it's being rotated, and the what is being instantiated, where it's being instantiated, and the rotation of what's being instantiated. Okay, so if we run this, what this should do is this should create 8 blocks starting at -4, or -4, +4, and then the next one will be -2.8, -1.6, because you have that 1.2 difference. So let's save this. Go back to Unity. Go to the GM object. And go to expand that out. And then square object, just like when we created the token object. So we take our square, we'll put it there. And so now it should be instantiated along the top 8 times. Absolutely perfect. Now watch this. Because we put that click function on a single square, we don't have to redo that. It carries along with it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. I can still count. Wonderful. Now, obviously, it's only doing the white tokens. Like I said, in the next video, we'll look at having it switch back and forth between white and black. So now what we need to do is we need to build on this. So we want this to happen not once, because this cycles through basically as a whole. This is basically cycled through once. So it goes through all the iterations, but this whole thing, so this gets done 8 times, but the thing as a whole only gets done once. So we want this to be repeated 8 times vertically. So what you do is you do, I don't know if they still refer it to as nesting, but when you put these together, so another public float, this time it is y, and it will start at +4, and then semicolon. And if x is, sorry, not x, it's y. Sorry, got to remember we're using a new variable. So y will start at 4, and in this case, it's going to be getting lower. So if y is greater than -4, then we want something to happen, and we want y minus equals 1.2 f, and then we do the squiggly brackets, and we put the other one here. So it even pushes it in to let you know that this is being repeatedly, it's going to be repeated while this condition is true. So let's just read through this to make sure I didn't make any mistakes. So y will start at +4. If it's greater than -4, actually let's believe that has to be -5, just like this one. Y in this case will be decreased by 1.2 f. And I did forget to do one thing. If you notice, I created the y variable and I have it cycling through what's supposed to be the y coordinates, but I didn't actually put y in here. So it's always important to remind yourself of what you're doing. We're not just creating a cycle, we're actually cycling through the coordinates that we want the objects to be instantiated at. So let's save this. And don't forget to save your scene. That's why this is now, I actually did a splice in the video. Make sure to save your work. So you just go up to File and you just do Save As and name your scene. And then let's just run this. There you go. So it's 8 by 8. Could be centered a little bit better. Maybe make the squares a little bit smaller. But again, since we put the functionality on one square and then we duplicate the square, that functionality is on every square now. Okay, so what we're going to do is that's going to end this first video because I think that's a good place to stop and kind of collect your thoughts and go through this. The next video is where we're going to alternate between white and black, so alternating between turns. And then we're also going to put in the functionality that when you place a piece, there'll be a check in all directions to see if there is a token or multiple tokens that need to be changed. So like if there is a single black one here, it would get changed. If there's 3 black here, those would all get changed when this gets placed, so on and so forth. So that will be the next video, and then I'm thinking there'll be a third video, which just kind of a few bells and whistles, like a title screen, maybe scoring, maybe a timer if you don't want people to take too long. The only thing I won't do, just to set expectation, is I'm really not going to create an AI. I'm not going to create a computer opponent to play against. That is just way out of my league. You have a whole lot of people trying to come up with AI that can play strategy games. So that's the only thing I really don't want to delve into. The person who requested this was really just looking for the basics of C#. So this would be a good, so-called couch co-op. We've got 2 people sitting in front of the TV and they can play it this way. Probably also won't do network play. I really don't have a setup to be able to test that effectively, but it would be fairly easy to create network play as far as you're really just changing the location of the new token that's been placed, as well as if the surrounding tokens have been changed. So you don't have a lot of data going back and forth. So I think that should about do it for this video. If you have any questions, please leave a comment. If you like this, please do a like. And like I said, so at least one more video to do the alternating gameplay between white and black and changing of the token colors when a token is placed, as well as maybe another video after that for, like I said, the bells and whistles, the title screen, scoring, timer, things like that. Okay, so that should do it. I hope you enjoyed this, and I hope that you found this useful.